First period, welcome. I love you so much that I'm recording the lesson that I should have done with you on Wednesday of this week, but couldn't because I was home with a sick kid. So this is specifically for you, first period. So take good notes. I'm going to walk you through the lesson on Law of Cosines. If you've stumbled on this video for some other reasons and you're not in my first period class or you don't even know who I am, my name is Mr. Cozad, and I'm going to walk you through how to apply the law of cosines and how to find the areas of side, 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 and side, angle, side triangles. Okay, so these notes, I actually already have these notes filled out, but what I'm going to do is I'm going to walk you through my thought process behind each one of these slides and offer you some pointers there. Okay, so here we go. So this is the law of cosines here, and what I would tell you is you could pause the video here and write this down in your notes if you'd like to, but I'm going to kind of power through this. So this is basically three different equations, but it's really kind of the same thing in all three scenarios. It's just kind of a pattern. So the pattern that I see here and the way that I remember the law of cosines is I know that this value over here is one of the three sides. Okay, so I'm going to take that side length and I'm going to square it. And I set that equal to the sum of the squares of the other two sides minus 2 times the length of the other two sides times the cosine of the angle that's opposite of this side on the left-hand side of the equal sign. Okay, so really what I look at here is I make sure that whatever's on the left-hand side and whatever I'm taking the cosine of are a side and an angle that correspond with each other or that match up. Okay, so these are the equations that we're going to use. The other piece of advice that I'll give you before we start is it is wise, let me make that a little bit bigger, it is wise to always find the largest angle first. It is wise to always find the largest angle first. So in that case, if you're given all three sides, the largest angle is always this side or the angle opposite of the side that has the greatest length, which we'll see in the next problem. Okay. So here's the first problem that I worked out. Suppose a triangular area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19 feet, 24.3 feet, and 21.8 feet, what angle of sweep should each sprinkler be set to cover? So this is a scenario where I'm given the measurement of three sides. So this is a side, side, side triangle. So what I did first is I drew the triangle and I labeled all three of the sides. Okay, and then what I did first is the very first thing that I did is I started by finding B. That was my goal, was to find one of the two angles. So what I did is I started with B for no particular reason. If you wanted to start with A, you could start with A. If you wanted to start with C, you could start with C. But I started with B because B is the angle opposite of the largest side. 24.3 is the longest side. So I typically start there. So here we go. I just plug and chug into my law of cosines formula. 24.3 squared is the side opposite of the angle I'm trying to find. And then I plug in 19 squared, 21.8 squared, minus 2 times 19 times 21.8 times cosine of B. And then honestly what I do is I plug this information into my calculator and I work it down to solve for cosine of B. Okay. Now before you go further, you're going to have to actually remember to make sure your calculator is in degree mode for this. If you keep it in radian mode, you're going to get some errors here. So once I get down here, cosine B equals 0.2967. To find the actual value of B, I take the inverse cosine of 0.2967, plug that in my calculator, and I get that B is approximately 72.74 degrees. Okay, so then I add that to my diagram over here. So then the next angle that I solve for is I solve for angle C. Okay, I solve for angle C. So again, I just use the law of cosines again. I take the side opposite of angle C, which is 21.8, and I do 21.8 squared equals the other two sides squared, so 19 squared plus 24.3 squared, minus 2 times 19 times 24.3 times cosine C. Same thing I did on step 1. I'm going to get it all the way down to find cosine of C equals 0.5158. I use my calculator to do this. Then I take the inverse cosine of 0.5158 and I get that C is approximately 58.95. So after I found those two angles, finding the third angle, angle A, is what I did next. And that one's actually super easy. I can use the property of triangles that all three angles must add up to 180 degrees to work backwards to find angle A. So I take 180, subtract 72.74, which I found up here, subtract 58.95, which I found down here in step 2, and then I solve for A to be approximately 48.31 degrees. Okay, so let's move on to the next one. Okay, so here's the next problem that we were asked to do. Solve triangle ABC. Now remember, when you're asked to solve a triangle, that's just a fancy way of saying find all the missing angles and all the missing sides. Okay, so this is what was given to me. So in this particular case, I have side, angle, side. So what I'm going to do is I'm going to use the law of sines to help me find A first. So that's what I did. I did A squared equals the other two sides squared, 14 squared plus 12 squared, minus 2 times 14 times 12, times the cosine of 39.4 degrees. And again, you can punch all of this in your calculator and press enter to get 80.362. And then obviously take the square root of that, and we get A is approximately 8.964. Okay, so then what I need to do next is I've got all three sides at this point. Now I need to find the two missing angles here. I need to find the measure of these two angles. So then what I do is I use the law of cosines to solve for B. Okay, because I know that I was given the opposite side of B is 12. So I have 12 squared equals 14 squared plus 8.964 squared, which is what I just found, minus 2 times 14 times 8.964 times cosine B. Again, use my graphing calculator, or any calculator for that matter, to get you down to cosine B equals 0.527. Take the inverse cosine on my calculator to get that B is approximately 58.197 degrees. Then the third step here, when I solve for C, angle C, is I take 180 minus 39.4 minus 58.197 to get that angle C is approximately 82.403 degrees. Again, I'm just using the property that the three angles of a triangle have to add up to 180. Pretty straightforward. The hardest part on this problem is honestly just making sure you're punching numbers in your calculator correctly. You just have to be careful with that. Okay, here's a problem that you can try on your own. I would pause the video here and try this on your own, maybe without looking at the answer choices here. But if you've already cheated and looked ahead, I would definitely try this and make sure that you can get this answer choice here. When I set this up, the first thing I did was draw a picture. And then what I did from there is I solved for m, the opposite side, and I did m squared equals 12 squared plus 17 squared minus 2 times 12 times 17 times cosine 54. And I get my m value, and as I look at my answer choices, there's only one that has the m that I want. So I was able to conclude the answer choice is B. If you want to find N and P, if that makes you feel good about yourself or you want some extra practice, please feel free to do that. You know what the answers should be. I did not do that because it was unnecessary based on the question that was asked. So the next thing that you're going to learn about is Heron's formula. And this is just another way to find the area of a triangle when you're given all three sides of that triangle. So you definitely want to write this down in your notes, and you're going to want to memorize this, okay, both parts of this, before your quiz. So Heron's formula says that the area is S times S minus A times S minus B times S minus C, where S is basically the perimeter. So we're taking essentially half of the perimeter of a triangle. So in this particular example, the first thing that I did is solve for S. And to solve for S, I added up the perimeter, 44, 47, 53, and then I multiplied that by 1/2 and got 72. So the S value I'm going to use is 72. And then I literally just plug in the values into this formula, 72 times 72 minus 47, times 72 minus 53, times 72 minus 44, punch that all in my calculator and get my area of 978.570. Super, super easy. If you're thinking, man, this is easy, it really is. All you're doing here is plugging and chugging away. Okay, here's one for you to try. You can go ahead and, again, find the perimeter first. If you want to try it on your own, pause the video now and do it, and then double check to make sure you get 191.6. But if you feel pretty comfortable with this, it's not a difficult problem. You can just kind of look through it. We take 19 plus 32 plus 21, that's the perimeter. Multiply the perimeter by 1/2, or divide it by 2, and we get 36. So then I use that to plug that in Heron's formula. okay, which is all my values. Sorry for my handwriting here. That's actually 21, but you probably already knew that. Plug it in the calculator and solve, and I get 191.624 feet squared. Please make sure that you put units of measurement on your answers here, because if you're asked for area, it needs to be, your solutions need to be given with units. Okay. And the last part of this lesson really is there's just another formula on finding the area of a triangle when you're given side angle side. So when you have a side angle side triangle, you're going to use one of these three equations. Now, it might be overwhelming for you to think, oh gosh, Cosette, we've got to memorize three equations. And really not. It's just a pattern that you're going to identify. So really, what this is, all three of these are the same. To find the area, you take 1/2 times 2 of the 3 sides times the sine of the angle that's in between those 2 sides. Okay, so for example, if you look at just this first equation, it's 1/2 BC sine A. B and C are located over here, and angle A is in between B and C. So if you remember that pattern, that it's 1/2 times 2 side lengths times the sine of the angle in between, you really will remember all these without actually having to memorize them. So let's see how it applies here on this example. So find the area of triangle ABC. Okay, so we're given angle A, and we're given side C and side B. So we're going to do 1/2 times the sides, 52 times 39, times the sine of the angle in between, 25.89. Plug that in our calculator, and we get our answer. It is that easy. Plug and chug. Let's look at one more. So here's another example using that area formula we just wrote down. So we're going to take 1/2 times 23 times 30 times the sine of the angle in between, which is 71. Plug that in the calculator, press enter, 326.2 centimeters squared. Y'all, that's it. That's all that we had for this lesson on law of cosines and finding the area of triangles. Go back and watch it again if you need. Come and talk to me or send me an email if you have any questions. I will see you next time.